Hello, and here I am again to talk about more fallacies, this time the false cause fallacy. The false cause fallacy is one of the more sophisticated ones we have in this section, and I also have a slightly different take on it than what's in the book. I think I can sort of simplify it, get it a little more straightforward, a little more clear-cut. So pay special attention on this one, if any. The most productive way to think of a false cause fallacy to my mind, is that it's this kind of argument that starts with a correlation. So you have a correlation between two things, let's call them X and Y, and the person jumps to the conclusion that X causes Y. So jumping from a correlation to causation. This is the main kind of format for this fallacy. And the problem with doing that is that there are alternative explanations of the correlation that haven't been ruled out. And there are some specific kinds of explanations that come up over and over again that we should pay special attention to and watch out for. One is that it's just coincidence. Sometimes it is in fact more likely that the correlation between two things is just a coincidence than that one of them really causes the other. There's a website that somebody came up with called Spurious Correlations, and there's all kinds of correlations on there. I'll just pull that up if it's still out there. I think it is the Spurious Correlations. Tyler, is it Vigan? I'm not sure. Put these together, and imagine somebody concluding on some of these things that there's a causal relationship. U.S. spending on science, space, and technology correlates with suicides by hanging, strangulation, and suffocation. So just imagine somebody drawing the conclusion, well, it must be because the scientists are under too much pressure, right? And committing these types of suicides. Or there's a correlation between the number of people who drown by falling into swimming pools and Nicolas Cage movies, right? So it's Nicolas Cage's fault. Stop making those movies, making people fall into swimming pools, right? So there really are such things as just pure coincidence. Sometimes that's more likely than that one thing causes the other. Next kind of problem that can happen is that you have identified a causal relationship, but you have things backwards. So you conclude that X is the cause of Y, whereas really Y is the cause of X. And that has implications for the conclusions that you draw about, what to do about this. So for example, somebody says, did you know that in police districts where they give out more speeding tickets, they have more accidents? Yeah, the tickets are just making things worse, right? You got to stop handing out so many tickets, right? Somehow the drivers are, getting aggravated by having these tickets or something. Well, that's not the most likely explanation. How come places where there's a lot of speeding tickets, there's also a lot of accidents? It's more likely that it's because the accidents happen, people speeding, and then when the police come out, they give somebody a ticket, right? So that's one other kind of false cause situation. I'm bringing up these ridiculous examples. I'll just point out again, we can deal with more realistic examples at a later time. But you have to see, right, you have to look at a case that's kind of absurd to see what are the features. So maybe the most common kind of problem, or the trickiest, right, the most tricky to detect, is when there's a third thing that causes both. So there's a correlation between ice cream sales and muggings. That is, the more ice cream gets sold, the more people get mugged. Right? Now imagine somebody drawing, there's something in the ice cream. We gotta stop, we gotta shut down the Dairy Queens until we figure out what's in the ice cream. It's making people go crazy. And again, part of stating these fallacies in a somewhat realistic way is that you don't always just state the conclusion immediately, but it's clear if I say people are going crazy from the ice cream that I think that the ice creams are somehow causing the muggings to happen. In order to see the problem, you have to think about something that's outside of the topics that I just brought up. What exposes the fallacy is not contained within the fallacy itself, unlike some of the other fallacies we've looked at. So you've got to think, well, what could be causing ice cream sales and muggings to go up at the same time? And it's the weather, right? Warm weather summer comes around and it's hot. More people are buying ice cream at the same time. There's more muggings because people are outside walking around, and muggers got to earn a living, so they come out to mug those people. So that's the correlation, going from correlation to causation. And the other, there's another variation on this I didn't put in my list, but it's in the book. When you identify a causal factor, but it's not the cause. In other words, something that is probably causally related doesn't necessarily mean that is the sole cause. And the example is, here's an example taken from the Hurley book. There's been tremendous advances in surgery, and therefore, and at the same time, people's lifespan has increased over the generations. So those things have gone together, and therefore, the reason we're living longer is because of the surgery. Well, that's undoubtedly a factor, right? But there are other things like knowing more about diet, knowing more about exercise, how exercise prolongs one's life, and people just being more health conscious. In general, that probably has, there are probably a number of factors there, right? So that falls under this category of jumping from correlation to causation. And you know, this another variety of this is where it's covered in the book, is where it's just a one-time event followed by another one-time event, and people jump to the conclusion that the first thing caused the second thing, which is often referred to as the post hoc ergo propter hoc version of the fallacy. Post hoc, after this, therefore because of this. So, you know, for example, I bring my car to get an oil change, and after the next morning after the oil change, the car won't start. And I say, what are those guys at that oil change place? They messed up my battery or something, right? They messed up the car. I don't know what they did. And of course, you know, just this happened, then that happened, and it's a one-time correlation from which I conclude this causation. So in that case, it's more likely that it's just a coincidence. So another kind of false cause fallacy is called the Gamblers Fallacy. We can put this under false cause. We could put this under some other things. It's actually kind of difficult to describe. It gets kind of abstract, but if you think of an example, it's not so bad. The Gamblers Fallacy happens when an event has not happened and it was statistically expected to happen, or it hasn't happened as frequently as expected. And then people think that it's more likely to happen the next time around. So for example, you're at the roulette table at the casino, and it comes up black like 5 times in a row. Now that's unexpected. Based on that, I mean, some people might conclude that the thing was fixed and it's always going to come up black. But let's say that that's ruled out. Right? That's not. We've checked. There's no way that it's fixed. So it has truly been random, but it's come up 5 times in a row black. Now, what a lot of people will conclude, or some people will conclude, it's more likely now to come up the other color, red, right? Because, you know, 5 times black in a row, it's supposed to be about half and half, right? And so they think now I'm going to change. I'm going to put my bet on red because, you know, it's due to hit red. And that's not how this works, right? Each time I spin the wheel, it's independent, so it's 50-50 chance. Actually, in that case, there's also green, so it's like 48 and 4 or something. But it's about a 50-50 chance that it could come up red or black. And the fact that it came up 5 times in a row black that's over and done with. That's in the past. So that doesn't affect this time around, this spin. And people will do this. People will do this with luck, where if I say I got in 2 car crashes this week, somebody's reaction is gonna be, well, you know, that's terrible, but at least you have this. You got your bad luck out of the way for like the next 4 years, right? You're not going to get in another crash for a long time, right? And that's not how luck works. It wouldn't be luck if you could predict it like that. That's not how it works. I mean, the reasoning that it does make sense, like say with the roulette wheel, if you spin this thing many times, spin it 10,000 times, you expect approximately half to come up red and half to come up black, right? And if I say it's probably not going to come up black 6 times in a row, before you spin it once, that's a good bet. But then you spin it, it comes up black, right? 5 times it comes up black. At this point, something unlikely has happened, which is now in the past. Now you can't still apply that reasoning that, oh, it's not going to come 6 times in a row, it's not going to hit black. You can't still apply that because it just hit black 5 times in a row, and that was unlikely, but it's now in the past. So the chances that the 6th time it'll be black, it's still 50-50, just like it always was, for each individual turn. Okay, so that reasoning, it may be a kind of statistical error, but it seems like it fits with false cause because the person making that argument seems to think the past spins of the wheel are somehow affecting this time around, which they're not. So we have 2 types under the Gamblers Fallacy, or I'm sorry, 2 subtypes under the false cause argument. One is the correlation argument. One is the other is the Gamblers Fallacy. Now with the correlation argument, it's important not to confuse this with hasty generalization, because a hasty generalization could involve a correlation as well as the conclusion of the argument, right? When someone does a sampling argument, sometimes the conclusion could be that there's a correlation between things. So, I do some sampling and I find out that there's a correlation between ice cream sales and muggings. I find that out through sampling. I didn't register every single ice cream sale, every single mugging, but I did a sample, right? And there's a potential for error there in that part of the argument. The false cause argument, that type of argument, which can be a fallacy, comes in after the correlation is established as a conclusion. It now becomes a premise in an argument in which you say, because the ice cream sales and the muggings go together, which I got from a generalization, right? Because of that, they're causally related. One causes the other. Now the correlation is the premise, and the conclusion is this causal connection. Okay, so that's the difference between false cause and hasty generalization. A lot of the language between those two is going to overlap because they could both involve talking about correlations. So be careful to separate between those two. Okay, so false cause is one of the more sophisticated fallacies, as I said, and worthy of its own video. In the next one, we'll talk about slippery slope and weak analogy. All right. See you then.